Hey, Lindenwood students. I had some requests for talk about some of the homework. So I'm going to talk about section 6.1 and 6.2. Um, okay, well, here's our Canvas page. I'm going to go to quizzes. Okay, wow, these are back in order. These are all scrambled on my Canvas for a while. Now somebody put them back in order. I hate it when stuff just happens. Anyway, here's section 6.1. We'll talk about a couple of these problems. Oh, let's see. I got a tablet here somewhere. Yeah. Okay, all of these problems start out the same way. They always you need to find this missing value of k, and and then they ask you something else generally. So we start out the same way for each problem. I'll look at question number 2 here. So first we find the missing value of k. As I said, all these problems start out the same way. So what you do is you use the fact that all of these probabilities here in this second row have to add up to 1. So I write, let's see, I need a pen. Where is my pen? Is that a pen? Yeah, how about blue? How about blue today? So 0.17 plus 0.21 plus k plus 0.17 plus 0.12 plus 0.11 equals 1. This is number 2 I'm working on. Okay, now just add up these numbers here together. You don't need to do any rounding for these or anything. So 0.17 and 0.21, that's 0.38, and 0.17 is 0.55, I think, plus 0.12 is 0.67, plus 0.11 is 0.78. So I get 0.78 when I add all those together if I haven't made an arithmetic mistake. Plus k is equal to 1. Then you subtract 0.78 from both sides, and I get k is equal to 1 minus 0.78, and I get that's 0.22. So for this one, k is 0.22 for question number 2. And then they're going to ask me another question. Find the probability that the number of bananas sold during a 20-minute period is less than 4. Okay, less than 4. So that's going to be the probability that you had 0 plus the probability that you had 1 plus the probability that you sold 2 bananas plus the probability you sold 3 bananas, because they say less than 4. So it only goes up to 3. So I just add those probabilities together. 0.17 plus 0.21 plus k. What is k? K is, I lost k. 0.22 plus 0.17. And so that's 0.17 and 0.21. That's 0.38, 0.6. I get 0.77. I don't think that's right. I might have an arithmetic mistake in there somewhere. Let's put it in there and see what happens. 0.77. Okay, so notice question 3. I have to find k again, so I'm going to do that the same way. and then find the probability that it donates more than 1 but less than 5 times a year. So more than 1, that would start at 2, and less than 5, so that would go up to 4. So I'd add the probability of 2, 3, and 4. All right. So once again, question 4, I have to find the value of k, do it the same way. And then find the mean or expected value of the score. And here they ask me to find the standard deviation. Those formulas are not too bad, but we can use our calculator for those. Let's erase this. All right. So let's find our let's do number 5. Let's find the missing value of k. So I get 0.08 plus 0.13 plus 0.16 plus 0.24 plus k plus 0.14 equals 1. So I add these up. 0.21, 0.37, 0.61, 0.75. Adding up those numbers, I get 0.75 plus k equals 1. So I get that k is equal to 0.25, subtracting 0.75 from both sides. Okay, now I'm going to get my calculator. Oops. Wrong button, calculator. And can I move it? I'm going to turn it on. And I'm going to press Stat Enter to enter these lists, 0 through 5 in L1. And then go over to L2 and put in the probability, 0.08, 0.13, 0.16, and 0.24. And what did I get? 0.25 for K, and then 0.14. Oops. I think I got them all in there right. Then I press Stat, arrow to Calc, one variable stats, L1, comma, L2. Enter. So if they were asking me for the mean, I would say 2.87 like they do in question 4. If they're asking me for the standard deviation, and you do have to do some rounding for this, what do they say? 4 decimal places. 1.4809. Right, because I'm going to draw, I'm not going to raise that because this is a 1. 1.4809. So let's see if that works. 1.4809. All right, let's submit this. Okay. Let's see if we got any right. Yay, so what I did in question 2 worked. Didn't answer any, I didn't answer anything on question 3. And that worked too. Okay, hope you get the idea there. Now let's go to 6.2. Do a couple of those. Okay, quizzes. 6.2. There it is. Okay, you have to think a little bit more on these problems. But you can see these first 4 questions all have to, 5 questions all have to do with weighted coins. So let's do, let's say we'll do question 1, 3, 6, 9. just to see some examples. A coin is weighted so that there's a 58.6% chance of it landing on heads. All right, so here, this is a probability of success or failure. So I'm going to these are all binomial. We're going to use the binomial PDF or the binomial CDF to do all these problems. And the first thing we need to use a PDF or a CDF is a probability of success. And so 0.586 is going to be the probability of success. So that's the first thing we want to write down. The coin is flipped 13 times. We also need to know a number of times the experiment was performed, and that's called little n. So that's going to be 13. And we also need to know what's the probability of something happening. In this case, and we call that x. So x is equal to 7 here. Notice that they're asking me exactly. If you see the word exactly, that means PDF. If you see a collection of possibilities, then we're going to use the CDF. Okay, so grab my calculator and clear this stuff off here. And I'm going to go to second distribution. Remember that the binomial is way up here, and I see the word exactly, so I'm going to use the PDF. The first thing that goes in here is the probability of success, 0.586, I think. The second thing that goes in here is, oh no, the first thing that goes in is n, I think. So I'm going to clear that. Try and start over again. I think the first thing that goes in is n. So second distribution, PDF, 13, we'll see if this works. 13, comma, the next thing that goes in is the probability of success, 0.586. And the last thing that goes in, I believe, is the value of x I'm looking for, in this case, 13. Oh. Yeah, that's a times 10 to the minus 4. That's 0.000. Let's oh, I'm sorry. No, it's 13. Oh, I said 13 and 13. Of course, I messed that up, didn't I? I'm only supposed to, the probability that's 7. And of course, this is the probability that you get 13 heads, and that's pretty small. That's what was throwing me. So I put in the wrong number here. This should be 7. So let's try again. Second distribution, go up here to PDF. N is 13. And comma, and then 0.586. And then comma 7. Okay, we got to do some rounding here. 0.2050. I'm not going to raise that 0 to a 1 because I only got a 2 following it. So I'm going to put in 0.2050. Okay, now a coin is weighted. Here's P right here. Here's N, the number of times I'm going to flip it. So at least 5 and at most 10. Okay, what do I need to do? At least 5. That means I need the probability that I get 5, because 5 is at least 5. And at most 10. So plus the probability that I get 6, plus the probability that I get 7, plus the probability that I get 8, plus the probability that I get 9, plus the probability that I get 10. Okay, I could find all these. I could use my binomial PDF to find 5, 6, 7, 8, 9, 10 and add them all together. But that would take me a long time. Instead, I'm going to use the CDF. If I do the CDF, up to 10, that will add up all the probabilities from 0 to 10. Then I subtract off the CDF at 4. That will add up all the probabilities up to 4. Then you'll see what I'll be left with is the probabilities from 5 to 10 added up. So that's the fastest way to do that. So let's see. This is question number 3. So let me grab my calculator. And I'm going to do second distribution. I'm going to go up to binomial CDF. And the first thing I put in is n. I'm doing question 3 here. 0.644. No, first thing I put in is n. What is n? 15. Comma. Then I got to put in p, 0.644. And then I put a comma. And then I want to add them up to 10. And then I'm going to subtract off. I'm doing this all in one thing. Second distribution, go up to CDF. Make sure you got a C here. And then I got the same n, 15. And comma, 0.644, the same probability of success. And then a comma. And then what do I want to subtract off here? 4. And I get 0.6627. So you see, you have to think a little bit more on these. And then I'm going to go to question 6. 6, 7, and 8 are all widget companies. So is 9 and 10. So these are all widget companies. The probability of success is going to be whatever 1 out of 50 in this case, 1 out of 49 in this case, and 1 out of 49 in this case. The number n is going to be however many widgets you have, 150, 150, 150. It's 150 in all of these. And once again, if the word exactly is in there, then I'm going to use the PDF. So I'll do question 6 here. Let's erase this. All right, number 6. Once again, P is 1 over 43 for number 6. N is equal to, how many widgets do I have? 150. And I have, see, exactly 3, so X is 3. And so it's exactly, so I'm going to use the PDF. Grab my calculator, clear all this stuff off, press second distribution, go up to PDF, because I see the word exactly, then put in N, that's 150, and then put in a comma, and I can put 1 divided by whatever, 43, number 6, yeah. 1 divided by 43, I can put it in like that, or I could put in the decimal. But I'll put it in like that. And then X, which is 3. 0.218, well, should I raise that 1 to a 2? I think so, because this is 5, but this is 55. So I'm going to raise that 1 to a 2, 1 to a 2, 0.2812. They're 4 decimal places, 0.2812. All right. Question 9. Oh, find the expected number of defective widgets in a branch. There's a simple formula for that. So I'm going to do question 9 and 10 because they don't use the calculator binomial CDF or PDF. They use some simple formulas that we had. So let's see how you use those. Let me get my. So for question 9, the formula for expected value is equal to n times p. Okay, so n is what? 150, and p is 1 out of 49 for question 9. So n is 150, and p is 1 out of 49. So that's the same as taking 150 divided by 49. So I'm going to use my calculator for that. 150 divided by 49. And I get 3.06 because they just want 2 decimal places. 3.06. Okay, that formula is on your crib sheet when you need it. And then the standard deviation. We had a simple formula for that too. Let me remind you what it is. Sigma is equal to the square root of NPQ. Okay, so in this case, that's the square root of 1,000 times 1/49th times 48/49. That's just 1 minus 1/49th is 48/49. You can just take 1/49th, turn it into a decimal, and then take 1 minus that on your calculator, and you'll get and you get the same thing. So I'm going to do second square root, and I'm going to do 1,000 times 1/49th times, you don't need to put parentheses here because the order of operations mean it's going to divide first, 48/49. And then close the bracket. And I get 4.47 if I round it off to 4 decimal places. 4.4712. All right, let's see if all these things worked. I always like to check make sure Canvas is calculating the answers the same way I do. So we answered number 1 right. We got that. Okay. It worked for number 3. Uh-oh. I answered 0.2812. Uh-oh. Did I switch those around there or something? I think I must have read that incorrectly on the screen. I put in 0.2812. The correct answer is 0.2182. Did anybody catch me on that? Let's see. That's the widget company. So let's go back. Second enter. See where we were doing that problem. Second enter. 150, 1 over 43. Here it is. Exactly 3. 0.21. You see, I switch it around. My dyslexia is acting up today. So that's not a problem. And let's check the last one. See if it worked. Yep. Oh, this didn't work. Let's see. Square root of NPQ. 149. 48/49. Oh, it's 1 out of 57. Excuse me. I used the same thing there. You know, these answers are... let's try it again. So that would be 1/57 and then 56. 57. So let's go try that again. Second square root 1,000 times P and Q changed here, and when I did 1/57th, and what would 1 minus 1/57th be? Times, that would be 56/57. See what that gives. What do I keep putting in 1,000 for? Sheesh. That's only 150. Let's try it again. It's very early in the morning, class. Okay, 150 times 157th times 56 over 57. Sheesh. 1.6079. 1.6079. Yep. So what I was doing was right. I just was plugging in wrong numbers. Anyway, I hope that helps a little bit, get you through this homework. And that's all for this.